So this is one of those questions from those confidence intervals cookbook problems that I gave in chapter 7. And so this is about, let's see, some high school says that at least 85% of their students are either in college, or graduates are either in college or they've already got a degree. And so somebody, they don't say who, did a sample of 60 former graduates, and to get it, 47 of them were actually doing what the high school predicted. So what they did is then I mean, let's say, so what? Some administrator maybe said, okay, so 47 out of 60, oh, that isn't 85%. So maybe something's up here. Maybe that claim of 85% is just a bunch of propaganda, or whatever, that isn't true. And so what we do with a confidence interval is, since we're kind of ignoring the 85% for now, but because we don't really know what the true population or true proportion of students who are in college or have a degree. So we'll use this as a point estimate for our center. We'll say, yeah, that's the true average. Let's see if the 85% is wrong. So what I did is, because this is a categorical variable and it's a binomial distribution, right? Either yes or no, they aren't in college or have a degree or in process. There's a fixed number of trials of 60. The probability that somebody's in college is certainly independent from each person to person. And is it the same? I'm going to assume so, but that one's kind of a fuzzy gray area. We don't really know. Um, but let's go with it. I think it's close enough. It'll probably work out to be good enough. If the sample's good, we could probably create a confidence interval and use that. So um, because it's looks like to be a binomial distribution, we can and I see 60 is pretty big sample. I think, you know I'm not really don't know how to say. I mean, maybe we could use that 85% to check. What if we do? I'm trying to think about in chapter 6 how we did the n times p has to be bigger than 5, and n times 1 minus p has to be bigger than 5. So we're stretching it a little bit with the 85%, but let's try that. So um, 80 students, or 60 students, let me undo that. 60 times 0.85, well, that's going to be bigger than 5. And 60 times 0.15, which is 1 minus 85, that's also going to be bigger than 5, because 10% of 60 is 6. So we're good. I think we're good to go. We're going to normal distribution. Um, as long as we're okay using that as a guesstimate of p. So I did the standard deviation. Remember, this is p hat times 1 minus p hat over the sample size, and take the square root, and I did some pretty liberal rounding. So we're going to call this, we're going to say the shape is normal, because it meets that criteria here. That the center is this, the standard deviation is here. So I went out to that David Lane normal calculator, because I knew the picture would do all the work for me. So there's that p hat number. And notice I'm going 2 standard deviations below the mean and 2 standard deviations above the mean. So confidence interval, if I'm doing a 95% level of confidence, we'll do p hat plus or minus 1.96 standard deviations, because remember that's the z-score. That's the z-score. So what the calculator did here is it did the 0.7833 plus or minus 1.96 times that 0.05 number that I typed in. So the lower fence of that confidence interval is about 68.3%, and the upper fence is about 88.3%. So does this interval capture the school officials' claim of 0.85? And notice the only way I use that 0.85 is to check to see if this would be a normal distribution. So I don't have that number influencing this calculation. So yeah, this confidence interval does capture the 85% number. So it the data doesn't contradict the school official's claim. I mean, it would not be unusual to get a sample of 60 students where only 78.3% of them were pursuing a degree or already had a degree. So that's the confidence interval lens, okay? And that's what we're looking for in Chapter 7. Now, if we put on a significance test hat, how is this different? Well, they're telling us that this is the middle of that distribution. They're telling us, hey, at least 85%, so 85% or more are enrolled in college. So again, if we do that check, here, just a minute. So what does this distribution look like? As we know it's normal, we can use a normal curve to represent it. So I went out to the David Lane website, and I said there's the center. I used the standard deviation, so it marked out the nice 68 and marked out, one standard deviation above, two standard deviations above, one standard deviation above, and one standard deviation below, or two standard deviations below, and that's what that distribution looks like. So now let's do some stuff about that hypothesis test. Let's formalize this a little bit. Oh, before we go there, see how this is within this result. Where was the p-hat number? Here's the p-hat number. See how that's within two standard deviations of the mean? So again, that's the same decision that the confidence interval came up with. And using the David Lane applet, that is the probability of getting a sample of 60 students where only 78% of them are in college or getting a degree. So that's more than 5%. That's not unusual, right? We couldn't say that this is not the center, right? So let's keep that. I just said we can't say that this is not the center. We can say this. The school officials claim that 85% or more. We can't say that they're wrong. So now let's formalize this for the significance test. So we know the claim that more than 85% are in college or pursuing a degree. And so here's my null hypothesis that says, no, and this is one reason I want to do this video. We can't say, so the center of this distribution is 80% or 85% or 0.85, and so the null hypothesis is nope, the center is the claim in this case, that 85% is the true mean, true center of this distribution. And then alternative hypothesis says no, that's incorrect, that it can't possibly be 85% and get a sample of the size with that low a success rate, or it could be above that success rate. But because our sample, how did I know to make this a left tail test? Because my sample standard deviation, my sample proportion is less than the stated center. So I knew it was going to be a left tail test. I mean, you can reverse this up and make the claim be H1. In fact, often the claim is H1. But in this case, I think it's easier to say that the school official's conclusion is the claim, not that we're trying to. If you were some student group and trying to say run the school down because you didn't agree with them, then you would probably say, hey, no, that less than 85%. That claim is wrong. In which case you could say that this is your claim, and make H1 be your claim. It's the same way. It's just the way you phrase the conclusion. Okay, so nice thing about this Rossman chance applet is see that probability. So it gives us the test statistic, it gives us the p-value, which notice that's the exact same thing that the David Lane calculator gave us. So this is nice because you don't have to do all that stuff about what's the center and do the standard deviation and some of that. So it's like confidence. I mean, a significance test is like a shortcut for confidence interval if you're looking for a specific thing. Okay, now then the last thing is how do you make a decision about this? How do you stage a conclusion? Well, actually, we're gonna fail to reject HO because our p-value is not smaller than, say, 5%. Usually 5% is our level of significance. That's limbo bar that it's going to be say this is too small a value to say it's not unusual. I'm sorry, I didn't say that. It's if the p-value is less than say 5%, then you can say, yeah, this is unusually small compared to the stated proportion and their stated mean, stated center. So that's kind of like that's why Dr. Stevens was talking about whether something's unusual or not. In this case, it's not unusually small because that p-value is more than 5%. I don't know if that's confusing or not. But another error that gives people a hard time, and this is why you saw when I wrote H1 or HO is P equals 0.85, and I said H1 P was less than 0.85, and I said this is the claim. Well, why I do that is now I can come back to help phrase a conclusion. I can say, see, the null hypothesis is the claim. So I did not reject the null hypothesis. I failed to reject the null hypothesis. So how you would word this, according to Dr. Stevens, you say there's not enough data to justify the rejection of the claim that, and then you fill it in. So this is boilerplate. This doesn't say too much. Um, then so what's the claim? And that's why I wrote the claim that more than 85% of students are pursuing the degree. I'm going to write that down. Um, but that's what you do, and this is how you use his phrasing for this. Okay, so hopefully this helps you decide on the difference between a confidence interval and a significance test, and let you be successful with this. Because in chapter 9, we're doing two samples since this continues. All right, let me know what you need.